This short video is going to help us look at problems where we might have the law of definite proportions or the law of multiple proportions exemplified. So what I have here are two samples of some hydrocarbon. They don't tell us how many carbons or hydrogens it has relative to each other, nor does it tell us the structure. So we take the sample and we run it or have it shipped off for elemental analysis, and they can tell you how many grams of carbon it has compared to the grams of hydrogen for that first sample. And you can do the same thing with elemental analysis with a second sample sent off, having 1.974 grams of carbon to 0.329 grams of hydrogen. So in these problems, you want to get to a lowest denominator of 1. So what I'll do is I'll set 1.76 or 776 over this 0.148. And if we do that, then we're going to get a lowest kind of denominator in the bottom of 1. And we can compare that to this one down here, doing the same thing. So if we run the math, I'll just bring the calculator out, 1.776, and we're going to divide that by that 0.148, we get 12. So we're going to put it as 12 to 1. So we're still talking about the grams of carbon over the grams of hydrogen. So it's kind of canceled out, the grams have, but this is still for carbon, this is still for hydrogen. So it gives us its lowest ratio, 12 carbons for every 1 hydrogen. Now if we do the same thing with the bottom here, 1.974 over 0.329, we can do the same thing and find out what the lowest ratio of carbons to hydrogens is using the gram amount. So 1.974 divided by 0.329 equals 6. So I'm going to now say 6 because the grams cancel out. G's to G's cancel out. And I didn't show that up here. But you're still going to have what it is still left in these units. 6 of carbon and 1 of hydrogen. Now it's obvious then that these two samples are not the same. Can you see why? If there was a law of definite proportions, it would mean that you'd always come to 12 to 1, because it doesn't matter how much of the sample you start off with in the beginning. If it has the same ratio of C's to H's, then you would have the same final ratio. But we do notice that we take the 6 and we can double it and we get to the 12. So this is a law of multiple proportions, stating that this here has 6 to 1, but then we jump up by, I guess, a multiple. We jump up by 6 to get to this ratio here, 12 to 1. And just because it's kind of fun to take it back to structure, we see then in this problem that by dividing this by this, so you just basically take what you have and you say, then that would give us a ratio of 2. 12 divided by 6, these cancel out, and we would have a ratio of 2 that goes up by 6 times a multiple, of 2. That would be our multiple, would be 2. To get this to this, we'd have to times it by 2. I was thinking about this. If it has 1H to 12, it's kind of, as far as weight, 1 gram to 12 grams, it's kind of a 1-to-1 ratio then of carbon to hydrogen. And I was thinking then this would fit the bill, because this would have a ratio of carbon to hydrogen of 1-to-1 mole-wise. But if you take the weight of 1 mole of carbon, it's 12, and you take the weight of 1 mole of hydrogen, that's 1. Now we know this has to have, I guess, a different ratio of carbons to hydrogen. So I'm going to propose this structure and see if it fits. For this structure, we would now have a ratio of not 1-to-1, but 2 to 1 for the carbon. So we can say, well, if this is the case, hydrogens are worth 4 as far as their weight in grams. This would be 24, 2 carbons, they each weigh 12 grams. So if we take and divide 4 into 24, we do indeed get 6 as a difference in the weight of carbon to the weight of hydrogen, 6 to 1. So this is a 6 to 1 ratio of weights of carbon to hydrogen. This is a ratio of 12 to 1. So this is, again, an exemplification of the law of multiple proportions. The key is to take those starting weights relative to each other and get to the lowest ratio. We did that for this one, it's 12 to 1. Do the same thing for the other one, and if it comes to 12 to 1, then it's a law of definite proportions exemplified. But if it doesn't come to the same ratio, you divide the larger by the smaller. 12, basically these cancel out. These 1H's, and it's 12 divided by 6. So we had a doubling. That was our multiple for this particular two samples. And we just had some fun. These would fit. Now, I'm not sure for certain these are it, but these would fit the bill. This would be your 12 to 1 carbons to hydrogens as far as weight. This would be your 6 to 1 carbons to hydrogens by weight. Thanks. Bye-bye.